Right, so number 2 says the region enclosed by the x-axis, the line x equals -2, and the line y equals -2x is revolved around x equals -4. All right, well, let's start by drawing this so that we can see the shape that we're working with. So we've got the x-axis, x equals -2, so vertical line here. And then y equals -2x. That's going to go through the origin and have a slope of -2. So down 2 over 1. So this triangle is the shape that we end up with here. And I'm just going to erase all the tails off of the edges of the graph. All right, it says that we're going to revolve that around the line x equals -4. So here is our axis of rotation, and this is our ghost shape on the other side. So we can kind of imagine what this looks like when it's spinning. So it's going to be like a funnel with a really large hole in the middle. So it is the washer method. You do have a hole in the middle. So this is going to be pi r squared minus r squared. And then we have to decide dx or dy. So it's like we just took the y-axis and moved it over a little bit. So it's going to be a dy problem. And so I'm going to use y values for my boundaries. So looking at our y-axis, it's going to be from 0 to 4. And if it is a dy problem, I need to go back and rearrange this equation. So to cancel out the -2, we're going to multiply by -1/2. So this is the equation that we would want to use. All right, so the outer radius, it's right graph minus left graph. So the right graph is this line, so that's our -1/2 y, minus the left graph is -4, so it would be minus -4, so +4. And then this is the inner radius. Again, it's right graph minus left graph. So the right graph is -2. And then minus the left graph, again, the axis of rotation is -4. So that's -2 plus 4, which would be 2. And the other thing that most people do is they'll just look at this and go, oh, from there to there is 2 units. But it does come from right graph minus left graph. All right, so this is one of the ones you had to do by hand. We're going to multiply this out. So you can write -1/2 y plus 4 twice off to the side. We're just going to distribute that all to each other. So that'll give us positive 1/4 y squared minus 4y plus 16. And then minus 2 squared is 4 dy. So combining these together, I'm just going to erase and fix that. 16 minus 4 is going to give us 12. And then we're going to do the antiderivative. So it would be 1/3 y cubed, but there's already a 1/4 there. So 1/4 times 1/3 will be a 12th. So 1/12 y cubed minus 2y squared plus 12y from 0 to 4. It's upper boundary minus lower boundary. Really, all you need to do is plug in the 4 because minus 0 is just going to be, like if you plug in 0 for all these y's, you're just going to get 0. And I told you didn't need to simplify any of it down, so you can just leave it like that. If you went further, that's fine, but you didn't have to. All you had to do was plug in the boundaries. All right, so do you guys see another one that you want to go over? What else would you like? All right, so number 5. So find the volume formed by rotating the region bounded by, all right, y equals 2x squared, y equals 0, and x equals 2, about the line y equals -2. All right, so let's graph this first. Y equals 2x squared. That's going to give us 0, 0, 1, 2, and 2, 8. And I'm only drawing this half of the parabola. The other half would be over here, but I'm going to end up erasing that anyway. We want y equals 0, and then x equals 2. So this is the shape that we're looking at. And we're spinning that around the line y equals -2. So that is right here. And then this is our ghost shape on the other side. So again, if you envision this being, you know, a three-dimensional thing, again, it's going to be like a funnel with a hole in the middle. So similar to the one that we just did, except this one's going to be a dx problem instead of dy. It's like we just moved the x-axis down a bit. So it's going to be pi r squared minus r squared dx. We're going to use x values for our boundaries, so 0 to 2. So outside radius, upper graph minus lower graph. So that's the curve 2x squared minus the axis of rotation, which is -2. So it would be minus -2, so plus 2. And then for the inner radius, let me color code that one as well. So again, upper graph minus lower graph. The upper graph is the x-axis, so that's 0. So it would be 0 minus -2, which is just going to be 2. And again, what a lot of people will do is just look at that and go, oh, that's 2 units. From there to there is just 2. But it comes from upper graph minus lower graph. So again, we're going to multiply all this out. You distribute all of this. It's going to give you 4x to the 4th plus 8x squared plus 4. And then minus 2 squared is 4. So conveniently, those are going to cancel. And then our antiderivative is 4/3 x cubed. Or no, I'm sorry, 4/5 x to the 5th. I subtracted instead of adding there, I'm sorry. 4/5 x to the 5th plus 8/3 x cubed from 0 to 2. Again, it's upper boundary minus lower boundary, but if you plug in 0, those are all just going to be 0. So you really just need to plug in the 2. All right, and then number 7. All right, so find the volume of the solid whose base is bounded by the graphs of y equals square root of x plus 2 and y equals x over 3, which is 1/3 x plus 2. All right, so let's start by graphing those. So for the square root of x plus 2, we're going to start at 0, 2. If we plug in 1, we're going to get 3. If we plug in 4, we're going to get 4. And if we plug in 9, we are going to get 5. And then y equals 1/3 x plus 2. So again, it's going to start at 0, 2. Slope is 1/3. So we're going to go up 1 over 3. And so you get this kind of like tiny little slice in here. So it says, and you have to imagine shapes popping up out of the paper. It says they are rectangles. And the cross sections are, the height is 3 times the base. So the height is going to be 3 times whatever we get for down here, perpendicular to the y-axis. So they're all going this direction. So that means that our base of our rectangle matches up with right graph minus left graph. And we're going to need to rearrange the equations so that they are x equals. So for this first one, we're going to subtract 2 and then square both sides. And then for this one, again, we're going to subtract 2. And to get rid of the 1/3, we're going to multiply everything by 3. So you have to distribute a 3 through there. So 3y minus 6. So these are the 2 equations that we're using. And right graph minus left graph. So the right graph is the line. That's going to be this one, the 3y minus 6. Minus the left graph, which is the curve. So that's going to be the y minus 2 squared. So when we go to set up the integral, we want to use y values for the boundaries. So that is going to be from 2 to 5. And inside of there, we're going to put the area of our shape. So it's base times height. So this whole thing is the base. The height is 3 times that. I'm not going to write that out, but it would be 3 times that exact same thing. So if you do base times height, it's going to be 3 times this quantity squared. So again, it's base times height. And this one you are allowed to just type in the calculator. Now I know it says Y, but we're going to type X. You have an X button, so that's just easier. So integral 2 to 5, 3 parentheses, and you could put the 3 out front of the integral if you wanted to do that instead. That will work the same way. All right, so 3x minus 6 minus x minus 2 squared, close parenthesis, squared dx. And we get 24.3. Now, some people put zeros at the end. That's awesome. I'm glad that you know you need 3 decimal points. If it just stops, like the answer is just 24.3 period, end of story, then you can just put 24.3. That is the full answer. It's not rounded or truncated or anything.